Hi guys, today I would like to talk to you a little bit about natural resources and the types of energy that they can be used to create. And we want to talk about the difference between a renewable resource and a non-renewable resource. Our environment can provide many important things that we need to survive, and we call the items that our environment provides us natural resources. A natural resource is just any useful material that's found in the environment. There are two types of resources that we find in our environment, and that is renewable and non-renewable. A renewable resource is just defined as a natural resource that cannot be used up, or it is one that can be replaced within a human lifespan. So examples of this would be soil, water, sun, geothermal heat or heat from underneath Earth's surface, wind, and then plants. Taking a look at some of these renewable resources and how they can be used to create energy, we can see that soil, it's something that we don't tend to think about, but it is formed when rocks and organic material are broken down through natural processes, and we use this resource for agriculture or farming. And with water, it's renewed through the water cycle, and it can be used to power turbines and electricity. Often this is near the site of a river or some type of moving water because the movement of the water will move the turbine. Solar energy or sun energy has to be harnessed through the use of tools like solar panels, and those solar panels will take in that energy and can be used to create electricity. Geothermal heat, or heat from underneath Earth's surface, there are pockets of that heat, and we actually have power plants that can capture the heat and the steam that's let off by that heat, and it can create electricity through the spinning of turbines by that steam. Wind is an interesting one because, again, it's kind of like soil and sun. We don't think about it, but it's always there in some way, shape, or form. And we can harness that wind with large windmills, and when the blades spin, they move a turbine that again creates electricity. When we see a lot of these windmills in an area, we call that a wind farm. And biomass energy, it takes plants like corn or soybeans and is used to create fuel alternatives. So you can actually find certain cars that run off of biofuel, and that's fuel created out of things like corn. But the big thing to remember with bioenergy is that all of the plants that we use have to be able to be grown again. So if we use them too quickly, we will find that process slows down because you have to give it time to regrow. And especially talking about the use of trees to make things like paper. Trees are a great renewable resource, but they take a long time to grow to full maturity. So if we just cut down a bunch of trees all at once, and don't pay attention to how much we're using, we don't pay attention to replanting those trees, we can find that renewable resource feels more non-renewable because we're using up our supply. Next, we have non-renewable resources. So these are natural resources that cannot be replaced after they're used, or in the case of fossil fuels, which we'll talk about here in a second, they take millions of years to create more. Basically, what this means is that a non-renewable resource exists in a fixed amount on Earth, and when it's gone, it's gone. And a very common type we hear people talk about are fossil fuels. And fossil fuels are things like coal, oil, and natural gas. Along with that, we'll find things like radioactive materials like uranium and plutonium that are used for nuclear power, and minerals, because believe it or not, your cell phone and a lot of the technologies that you use rely on certain minerals to help the technology function. So non-renewable resources, when they're gone, they're gone. Okay, I did also want to talk a little bit about a particular type of non-renewable energy that we have called nuclear energy. So nuclear energy is non-renewable because of the radioactive materials that are used in the process of creating it. And I feel like it's important to talk about because it is used here in the United States, but it's not our main type of energy, and therefore we don't often hear people speak about it. And it does have a very interesting history. So nuclear energy uses radioactive materials like uranium, plutonium, cesium, and polonium to create energy. But before this type of energy was ever used to power cities and homes, it was actually used as a military weapon during World War II. But putting our foot on the brake and backing up a little bit, we want to talk about how nuclear energy is created. So everything in this world is made up of atoms, and within atoms there are smaller units called protons, neutrons, and electrons. And the nucleus, or center part of our atom, that contains protons and neutrons. So in the time leading up and through World War II, scientists discovered that if the nucleus of an atom was split in a process called nuclear fission, it releases a lot of energy in the form of heat. And over time, scientists began to learn that if they could control that reaction, you could harness the energy that was created. But before nuclear fission could be used as a way to, like I said, power cities, it was used to create something called an atomic bomb. So this weapon was used by the United States to end World War II, and what happened is that towards the end of World War II, the United States dropped 2 atomic bombs on Japan, one on the city of Hiroshima, and another on the city of Nagasaki. This action by the United States, it would go on to become one of the most controversial military actions in history because of the devastation brought to the cities. So basically, to help us understand that devastation, we want to take a look at what History Channel says. So History Channel says the explosion immediately killed an estimated 80,000 people. Tens of thousands more would later die of radiation exposure. 3 days later, a second B-29, which is a plane, dropped another A-bomb or atomic bomb on Nagasaki, killing an estimated 40,000 people. After World War II ended, basically scientists and military members alike thought, okay, we need to focus on how to make nuclear energy work in a positive way instead of just as a method of war. And scientists and engineers have found a way to do that. We've found a way to harness the energy from nuclear fission through the use of nuclear reactors. A reactor is basically a big machine that allows for the splitting of atoms to be more controlled and has helped to become a relatively safe way of creating power. But with that said, there's a lot of misconceptions about nuclear energy, and it does have its pros and cons. One thing that people often point out when they're fearful of or uncertain of nuclear energy is that if something goes wrong with a nuclear reactor, it can be an absolute disaster. The radioactive materials, so the uranium, plutonium, cesium that we use to help create the power, they give off or emit harmful alpha, beta, and gamma radiation. And radiation is really bad to be exposed to, especially in high levels that can happen during a nuclear power plant disaster. If a person or plant or animal is exposed to high levels of radiation, it can cause severe radiation burns, and radiation burns are really weird because there's the initial burn, but then they can continue to show up in new burns from the radiation weeks, months, and even years after that exposure. And beyond just the initial acute radiation sickness that can happen, it can also cause long-term health issues such as cancer. And in the first of the 2 videos that we're going to take a look at, you can see what happens when a nuclear reactor has something go terribly wrong with it. And in this case, we're looking at a reactor that was not only not constructed properly with proper safety measures in mind, but also potentially some human error on the part of the people operating the plant. Whereas with the second video, we're going to talk about some positive things that come from nuclear energy.
The world's worst civilian nuclear disaster took place when a reactor exploded at the Chernobyl power plant in Ukraine, then part of the Soviet Union. Present-day Belarus received 60% of the initial fallout. The radioactive cloud spread further to cover most of Europe. The Chernobyl nuclear power plant was one of the Soviet Union's most advanced facilities. The first 2 reactors became operational in the late 1970s. The 4th reactor was the newest, going online in 1983. On April 26, 1986, technicians prepared to test the backup cooling system in reactor number 4. but the routine safety drill went horribly wrong. A nuclear reactor is like a giant steam engine. Uranium fuel rods react to produce a massive amount of heat. That converts water into steam, which drives huge turbines to generate electricity. Control rods are inserted in between the uranium to slow the reaction. And it's crucial for cooling water to be pumped around the core to prevent overheating. But as the test began, almost all of the control rods were removed, and technicians lost control of the flow of coolant. Temperatures soared, and extreme heat began to melt the core. At 1:23 a.m., Reactor 4 exploded. It spewed 8 tons of radioactive debris into the atmosphere. 115,000 people were evacuated from a 30-kilometer zone around the plant. The battle to put out the fires inside lasted for 15 days. More than 500,000 military and civilian personnel were drafted to deal with the accident and its aftermath. 31 of the initial firefighters and plant workers died within days from acute radiation sickness. The toxicity of the radioactive cloud was equivalent to 400 Hiroshima atomic bomb explosions. Crews hastily built a concrete sarcophagus to encase the entire reactor to prevent more radiation from spreading. Inside, there remained 200 tons of radioactive fuel. The remaining 3 reactors continued to operate due to energy shortages in Ukraine. It wasn't until the year 2000 that the Chernobyl complex was completely shut down. With the concrete sarcophagus crumbling, the international community began to build a new confinement structure for Reactor 4. It stands 110 meters tall, higher than the Statue of Liberty, and it's wide enough to fit a ship the size of the Titanic. At a projected cost of $3 billion, construction is scheduled for completion in 2017. One of Chernobyl's iconic red and white chimneys will be dismantled, and the massive steel dome will slide over reactor number 4. The confinement structure is expected to last for at least 100 years.
And like I said, this next video is going to talk to us about some of the opportunities, positive things that can come from nuclear energy.
What is nuclear energy and how does it work? Since the beginning of the Industrial Revolution, the demand for energy has increased dramatically year after year. Today, the majority of this demand is met with the combustion of fossil fuels. With the recent disaster at Fukushima, as well as the ever-present effects of the events at Chernobyl and 3 Mile Island, nuclear power has lost some of the enthusiasm that once surrounded it. Because of the rising costs and harmful effects on the environment caused by fossil fuels, people are looking for ways to replace our dependence upon them. While renewables such as hydroelectric, solar, and wind energy have proven to be worthy replacements, they are still a ways off from meeting our needs. Nuclear, on the other hand, has all of the technology required to be used on a large scale. In the US, nuclear accounts for 21% of the electricity produced, whereas coal contributes 41%, natural gas 24%, renewables 12%, and petroleum only 1%. Despite the current level of adoption, there is still a great deal of misconception and fear surrounding nuclear energy. Now, let's see how most nuclear power plants actually work. First, you have the fuel, usually uranium, which must be mined, enriched, and then formed into pellets that are placed in rods within the reactor. The atoms of uranium undergo a controlled chain reaction which emits heat. Pressurized water around the reactor vessel is heated and circulated through pipes in a steam generator, which produces water vapor that spins a turbine attached to a generator. After leaving the turbine, the steam is condensed so that the cycle can continue. The benefits of using nuclear fuels are numerous. The lack of carbon emissions, the ability to create huge amounts of energy, and the reliability of power production are all extremely important. As there are no fossil fuels used in the consumption of uranium, direct carbon emissions are non-existent and indirect emissions are limited to the construction of the facility and obtainment of fuel. Unlike many renewable methods, nuclear plants do not depend on the conditions around them to function, which would make them perfect for the constant baseload of the electrical system. The main concerns surrounding nuclear energy are safety, waste management, and total expense. Contrary to popular belief, nuclear is among the safest sources of energy that is currently in use. Despite the seemingly huge impact reported by the media, there have been no deaths as a direct result of the meltdowns at either Fukushima or 3 Mile Island. Even in the case of Chernobyl, the total number of expected deaths is quite low. In comparison, deaths due to the use of coal are over 10,000 per year in the US alone. However, deaths are not the only impact which an accident can have. They can force people out of their homes and change the land around them for a very long time. For the treatment of waste, there are 2 main options that are currently employed: containment and reprocessing. Containment is the placement of exhaust fuel in safe containers where it will remain for a very long time. The second, and more expensive method, reprocessing, treats the waste so that it can be used within a reactor again. Nonetheless, reprocessing is not currently practiced in the US due to a lack of facilities necessary. Furthermore, costs come mainly from the building and regulation of plants. These high initial costs can be mitigated by focusing on uprating current plants instead of building many new ones. Finally, technologies are being developed which can further decrease these disadvantages. So then, how can nuclear play into our energy future? Combined with renewable sources, nuclear allows us to enjoy our energy needs without the impact on our environment that is coupled with fossil fuels.
Alright, so lastly, taking a look, just kind of summarizing the pros and cons of renewable energy using renewable resources and non-renewable energy using non-renewable resources. So with renewable energy, the positives, the pros, are that basically the quantity is limitless. It will never run out so long as we are using them carefully. The energy is most of the time free to use. It's environmentally friendly. It is great for our environment. We're not hurting it in any way by using them. However, the cons are that it can be difficult and expensive to set up, and we don't always have enough of those renewable resources to use because they often require large amounts or are dependent upon the environment or even the weather as to how much is available. Whereas with non-renewable resources, our non-renewable energy pros are that it's often cheaper to use, it's easier to use, and it can be more efficient because it requires just a small amount of the resource to produce a large amount of power. But some pretty big cons exist with non-renewable resources, and that is they'll run out someday. They're non-renewable because eventually they will run out. They are causing serious environmental changes, and that comes from things like releasing toxic gases that are contributing to global climate change. And eventually, as our supplies of those non-renewable resources get low, the price of those resources will rise. Alrighty guys, thank you for watching. Be sure to go take the check for understanding after you get done with this video.